Well, here's how I'm going to write it for 1. E minus 7. What does that mean? In algebra, what would that mean? What? No, what would E minus 7 mean, Darby?
Everybody minus 7.
Everybody but 7. E minus 7. Okay, because only 7 voted otherwise. Okay, well, let's see what it is. Oh, my prediction. My prediction is 1. Abracadabra.
Yeah.
Am I a magician or what?
Yes.
All right. The fraction is 25 divided by 1. 25.0 is the decimal. Did it get bigger or smaller?
Bigger.
Did the work get easier or harder?
Easier.
Now 1 will lift 25. If you can find a machine that has a mechanical advantage of 25, it's a very good machine. Now, it's possible to calculate the mechanical advantage of any machine. See, those machines I drew on the board for you were simple machines, but most machines are complicated machines. A car, a bicycle, they're complicated. They're combinations of pulleys and inclined planes and gears and levers. Okay, but there are people who can calculate the mechanical advantage even of complicated machines like that. They're called engineers. If you want to learn how to calculate the mechanical advantage of a complicated machine, you just about have to go to a 4-year college and take engineering. And then you'd get enough math so that you could do that. I can't do that. About all I can handle is a lever. Okay. Because I didn't get the kind of math that an engineer gets. All right. Well, now I'm going to take the nails out of here, and I'm going to move the fulcrum farther from the middle, farther from the work. Okay, now it's 1. It's minus 1. Minus 1. An inch farther away from the work in the middle. Okay. 1, 2, 3, 4, 5. So this time the work is 5. All right, now, if you've been paying attention and you can analyze the chart, you should be able to pick the best one of these. Greater than 5, equal to 5, and less than 5. All right, how many think the effort will be greater than 5 this time? 7. How many think it'll be exactly 5?
Wait, no.
I can tell you're rapid learners. Nobody voted. Why couldn't it possibly be exactly 5, Jackie?
It's crude.
Oh, right, because it's crude, but there's another reason. Why couldn't it be exactly 5?
Because the fulcrum isn't in the middle.
The fulcrum isn't in the middle. Okay, good. All right. Does anybody, well, nobody voted for exactly 5. How many vote for less than 5? Well, what do I put here? E minus what?
7.
E minus 7. What does that mean?
Everybody
but 7. That's how you learn to write things in algebra. Okay, well, most of you voted. Now, I was able, let's backtrack a minute. Did anybody figure out how I knew that it was going to be 1 each time here? Not because I've done it so much. That's not why. A lot of people think because I've done it. No, there's a simpler reason than that. How did I know it would be 1 each time here? What do you think, Harley?
Because in cup A.
Well, let's look here. There were 7, 15, and 25.
Because in cup A there was always more than cup B. There's always.
That's true, but that's not the reason why I knew. Darby, why do you think?
The fulcrum wasn't in the middle.
Okay, that's true, but that's not the reason why I knew either. Emily, you've come up with some pretty good answers. What do you think?
Because the fulcrum was closer to the work.
Well, that's true too, but that's not the reason. Here's the reason why. It's very simple. You guys tend to make science too complicated. Hey, when the work was 25, which nail out of the 25 nails made the work end go down? Which nail was it that made the work end go down? Which one, Darby? Nail number what?
Nail number 25.
Nail number 25 made it go down. One nail made it go down. Okay, so I knew then that if I put one nail in the other end, that end would go down. See, essentially it only took one nail, the last nail, to make it go down. So therefore I knew that if I put one nail over here, it would make it go the other way. Pretty simple, right? Okay, well, let's see, we're on -1, and most of you voted for less than 5.
What's your guess?
Okay, yeah, most of you voted for less than 5. Oh, well, I guess, I didn't count you, so I can't, it's pretty evenly divided between more than 5 and less than 5. You know what that tells me? That tells me you don't really know. If your votes are evenly divided, it tells me probably you don't know. Okay, well, this is harder to predict this time. Even I can't predict this accurately, but I can predict which one of those is going to be. Okay, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Oh my gosh.
It's 12. So the fraction is 5/12, and 5 divided by 12 is 0.4. Is that smaller or larger than 25?
Smaller.
Hey, if there's anybody in here that doesn't know that 0.4 is smaller than 25, you better go back and repeat 4th grade, all right? Okay, now I'm going to move it to -2. -2. Okay? I want to get some predictions. Well, the mechanical advantage got smaller. Did the work get easier or harder?
Harder.
Harder. It took 12 to lift 5. That's harder. Okay. Well, let's get some predictions on the work is still 5. The work is still 5. Okay, let's get some predictions what the effort will be with it on -2. Who wants to predict? Jeremy?
22.
Jeremy says 22. Okay, who wants to make another prediction? Jonathan?
23.
23? You're the cautious one. Okay. Jessica?
21.
You're cautious also. Well, those are so cool. I guess we can go. How many think it'll be 21? 21? Anybody? 2 people. How many think it'll be 22? How many think it'll be 23? Okay, well, most of you voted for 22. Now, I'm really pleased that all of these predictions are more than 12. Why? Why am I pleased that they're more than 12? Again, a simple answer. If you start giving me a complicated answer, I'm going to go to somebody else. Why am I pleased that all of those predictions are more than 12? Why do you think, Jake?
Because 12 was equal to 5. I mean 12 was 1.
Oh, that's not it.
Because the fulcrum was moved.
Well, that's true, but that's not the reason why I'm pleased that they're all more than 12. Jeremy?
This is like 12 minutes.
There's already 12 in it.
Oh.
So it has to be more than 12. Simple, right? Okay. Well, you know, sometimes it takes a really bright person to think of a simple answer. Everybody else tries to think of a complicated answer. I'm kind of a simple person. Some people call me simple-minded. Okay. Okay, what we've got in there now? 12, 13, 14, 15, 16, 17, 18, 19, 20, 21.
Yeah!
Raise your hand if you ever heard the phrase simple-minded applied to anybody. Is that good or bad?
Good.
Well, it could be good.
Bad.
It could be good if your simple ideas are better than the complicated ideas. Okay, 5 divided by 21. That's 0.2. Did it get bigger or smaller?
Smaller.
Smaller. Did the work get easier or harder?
Harder.
Harder. Now it took 21 to lift 5. Okay. Now we're going to put it on -3. 3 inches from the middle. Okay. I want to get some predictions. Look at the chart. See what the pattern is. And then give me your prediction. Who wants to make a prediction? Jessica?
31.
31. Who's got another prediction? Megan?
37.
Oh, you guys are cautious. Okay. Tanner?
33.
33. Well, that's 3. Okay. Well, they're all so close, I'm not even going to have you vote. But why am I pleased that they're all more than 21? Give me a simple answer now. Why, Darby?
Because there's already 21.
There's already 21 in there. Good. Hey, you're rapid learners. Okay, well, let's see what it is. 21 in there now. 22, 23, 24, 25, 26, 27, 28, 29, 30. We're getting close. 31, 32, 32. Okay, the fraction is 5/32, and that calculates out to be 0.1. Did it get smaller or larger?
Smaller.
Smaller. Did the work get easier or harder? Harder. Now it took 32 to lift 5. Okay, now over here, you'll want to do this on the right side of your chart because you have more room on the right side of your chart. But here's what I'm gonna put the pattern here. For these 3, the fulcrum was in the middle. So, as it should be, they were close to 1.0. Okay, for these 3, the fulcrum was getting closer to the work. Okay, so the mechanical advantage got progressively larger. For these 3, the fulcrum was getting farther from the work. Okay, now, by analyzing the chart, it should be possible for somebody to come up with a conclusion that answers this question: how does the location of the fulcrum affect the mechanical advantage? In order to make it easier for you, I'm going to write a conclusion with some blanks in it and see who can fill in the blanks. Here's what we're going to write. As the fulcrum gets closer to the work, the mechanical advantage gets blanker and the work gets blanker. Okay. Now, let's take them one at a time. Follow along as I read and then tell me if you know what word goes in the blank. As the fulcrum you should be able to figure out which words go in the blank by looking at the chart. As the fulcrum gets closer to the work, the mechanical advantage it's either bigger or smaller. I'm going to have you vote. Bigger or smaller. As the fulcrum gets closer to the work, the mechanical advantage gets. How many say bigger? How many say smaller? Well, I guess you missed the point of the lesson. Seven, closer, closer. Closer, closer. Is it bigger or smaller?
Bigger.
Bigger.
Oh yeah.
Okay. That's the main point of this lesson. It gets bigger. All right. Now, and the word gets.
Small.
I'm going to have you vote on easier or harder. The word easier or harder. How many of you think that the word easier goes in? How many think the word harder goes in? Well, look. 1 inch closer to the work, 2 inches closer to the work, 3 inches closer to the work. 1 lifts 7, then 15, then 25. Is it getting easier or harder?
Harder.
Easy.
If 1 can lift 25, is that easier or harder than 1 lifting 15? Easier. Okay. Well, you guys aren't as sharp today as you usually are for some reason. Maybe it's because you're anticipating Christmas vacation. Okay, as the fulcrum gets closer to the work, the mechanical advantage gets bigger and the work gets easier. Now, does that fit the chart?
Yeah.
Is there anybody that sees how it doesn't fit the chart? As the fulcrum gets closer to the work, closer, the mechanical advantage gets bigger, then bigger. Okay, that worked. And the work gets easier and easier. Okay, so it does fit. Now, if you want to express it in terms of what happens when the fulcrum gets farther away from the work, here's what you can do. As the fulcrum gets farther, I'm doing this in blue so you can see it easy. As the work gets farther from the work, the mechanical advantage gets, instead of bigger, what would this be? Smaller. You can't do this very well unless you have colored pens. And the work gets, instead of easier, what would it be? Harder. Okay, so the blue
It's just the opposite.
right, it's just the opposite, Harley. Harley noticed that. Okay, now, is there anybody that doesn't have this copy? Okay, good. So, because I want to erase it and tell you a story about my childhood.
Darby needs it.
We'll get it from somebody else, Darby. I want to make a diagram on the board. It's okay to copy in my class. Somebody let Darby copy the chart. Okay. Darby was so involved in thinking about the concepts and the answers to the questions I asked, she forgot to copy the chart. That's good, Darby. Okay. Now, have you ever noticed that I tell a lot of stories about my childhood?
Yeah.
Okay, well, I had a lot of things happen during my childhood. All right. I had a very long childhood. All right. When I was your age, 68 years ago, my dad had a 1938 Chevrolet. It had a big hood ornament.
That thing's worth a lot.
1938 Chevrolet. Hey, 68 years ago, that was a new car. Okay? It had wheels. Even back in those days, cars had wheels. Okay? All right? Now, if my dad got a flat tire, he didn't like to use the car jack because car jacks weren't very efficient then. They didn't have very good mechanical advantage. Plus, in order to use the jack, you had to crawl under the car and place the jack under the axle. And nobody liked doing that, particularly if you had your Sunday best clothes on. So here's what my dad did. he had, oh, I forgot to draw the bumpers, because the bumpers are an important part of this story. There's the front bumper and there's the back bumper. Okay,